Here we go, working through the advanced practice sheet, the odd-numbered problems. The reason this is advanced is that it requires you to do the factoring yourself before you do the reductions. And, well, there you go. These also all happen to be divisions, so we'll get some practice there with divisions. All right, the way it needs to go is you've got to start by factoring everything you have. So let's do that. Here, 3x plus 4, nothing to factor. No GCF, no quadratics. Down below, those are both even, so divide out of 2. That's going to leave you with a 3x plus 4. Ooh, so right away we can see those are going to end up reducing. Next up, I'm going to do two things at once here. I'm switching the divide to a multiply, and we're going to now flip this upside down. So let's focus on the original top, which we're going to put those factors down here on our new bottom. Ooh, GCF, no, but it can only be 7, and they don't have a 7 in common. So we're looking now for two numbers that multiply to 7 times 72, which is 504, and that add up to negative 71. So because they multiply to a positive, they have the same sign. Because they add up to a negative, they're both negative. So two negative numbers is what I'm after. Now do some guess and check. You're looking for factors of 504. So I start with 1 and 504, then 2 and 252. Just kind of work it down that way. You will eventually end up with a negative 8 and a negative 63. Put those now in a box. And quadratic upper left, constant lower right, and then a negative 8x and a negative 63x. Now GCFs to the top and to the left. So these have in common a 7x and a minus 8. So there's one factor. And then these have in common a 1x and a minus 9. And just a quick check, right? So it's be 7x squared minus 63x minus 8x plus 72. Works out okay. So that was the original top, which now became the new bottom. Now, I'm just going to switch colors to make it a little easier to see. Let's do the same thing down here below. So 7 times 56. So I want numbers that multiply to negative 392 and that add up to 41. Do a little guess and check. So what we'll see is they multiply to a negative, so one's positive and one's negative. They add up to positive 41, so the positive number's bigger. You're going to end up with a positive 49 and a negative 8. Put those now into a box. And here's what we have, a 7x squared, a minus 56. Then we'll have the 49 in one of the boxes with an x on the end and negative 8 in the other. And what do we have? Going up, I got an x and a plus 7, and then across a 7x and a minus 8. So those factors now go up on the top. Okay, next up, Cancel Fest, 2000, whatever year it is. So the 3x minus 4 and the 3x minus, or sorry, the 3x plus 4 and the 3x plus 4. The 7x minus 8, the 7x minus 8, and that's it. So we're left with, on the top, an x plus 7. And on the bottom, don't forget that 2 in front and an x minus 9. Now some restrictions. So for restrictions, we've got to look 3 places, yeah? I've got to look here, here, and here, since those at one point were all in denominators and we can't divide by 0. So from here, x can't be negative 4/3. From here, x can't be positive 8/7, or positive 9, or positive 8/7, but that's already listed, or negative 7. So together, the reduced expression with the restrictions is our final answer. Next up, let's go again. Looks like we're going to have mostly GCF factoring this time. So up here, what do these have in common? A 7x squared is what they have in common. That's going to leave us then with a 5x plus 3. And then down below, they have an 8 in common, leaving us with an x minus 4. Change to multiply and reciprocate. So we're going to have another 8 quantity x minus 4 that is moved to the top. And then for here, looking for the two numbers that multiply to 5 times negative 24. So they multiply to negative 120. and add up to negative 37. So that's not super obvious. They multiply to a negative, so one's positive, one's negative. They add up to a negative, so the negative number is bigger. Actually, it's not that tough to figure out. It ends up being negative 40 and a 3. So in our box, the quadratic, upper left, the constant, lower right. One of them gets the negative 40. One of them gets the 3. And then to the top and to the left. So an x, and then what would this be? A minus 8. And then over here, a 5x and a plus 3. Ooh, that's nice. It won't always work out this way that so much cancels, but for these practice problems, it probably will. Right, let's reduce things. X minus 4, 5x plus 3, 5x plus 3, 8. Okay, that's everything that cancels. So we're left with 7x squared on the top. On the bottom, all that's left is the x minus 8. Now restrictions, remember you got to check those 3 places. So here, x can't be 4. Here, x can't be negative 3/5. Here, x can't be 8. And here, x can't be 4, but we already have that one listed. So the reduced expression, together with the restrictions, is what we're after. Next up. Ooh, looks like all GCF factoring here. Okay, let's give it a go. So 20 would be what, a 4a that these have in common, leaving us with a 5a minus 2. Here then, on the bottom, they have an 8 in common, leaving us with a 5a minus 7. Flip this upside down now. It's going to be another 8 times 5a minus 7. We're going to make that a little better. And then down below, now notice here how the a is in the back. All that means is if we factor out a negative, the order of subtraction will change. So I'm going to take out a negative 7 this time. That's going to leave us with a minus 2 and a plus 5a. Now, if you didn't do that, if you just took out a 7, what you would have here in this factor then would be 2 minus 5a. That's not wrong. It just makes it a little harder to see that you can cancel with what's up here. But if those 2 factors are the same except for the order of subtraction, you can reduce them. It leaves a negative sign behind. That's where that negative is coming from. Okay, let's reduce 8 with 8. 5a minus 2, 5a minus 2, 5a minus 7, 5a minus 7. Ooh, lots cancels this time. So we've got left over just the 4a on the top and then a negative 7 on the bottom. We'll typically put the negative in front of the fraction. And now restrictions. We're just going to make a note that, hey, a can't be 7/5. A can't be 2/5. And a can't be 7/5, but we already have that one listed. And the reason that I'm checking all 3 places is that these were divisions. If it's a multiplication, remember, just check the bottoms. If it's division, check those 3 locations, since at one point they were all bottoms. Next up. For this first one, no GCF, so I'm looking for 2 numbers that multiply to 18, add up to negative 11. That's going to be negative 9 and negative 2. 2n squared and a 9. So that's going to leave us with a 2n minus 9 and an n, and then minus 1. So there's the first set of factors. Now down below, let's do this one in purple. So looking now for 2 numbers that multiply to negative 36, add up to negative 5. That's going to be negative 9 and positive 4. So 2n to the second minus 18. And then here, one of them gets the negative 9, one gets the 4. So here, 2n minus 9 in common. Well, that's nice. That'll end up canceling away. And then here, an n plus 2. Let's keep going. This one here, just a GCF, divide out the 7. And then down below, This one's going to have a few steps to it. So step one, I'll do this one in green. Step one, notice these are all divisible by 7. You got to take out that GCF first. And then whenever your leading coefficient now is a 1, it's just 1n squared, you can just find your two numbers. It's going to be multiplies to 10, adds to 11. Well, that's 10 and 1. And so there are my factors. One of them is n plus 1. The other one is n plus 10. Now let's reduce. Gone and gone, gone and gone, gone and gone. We're left with on the top just the n minus 1, but on the bottom, we've got n plus 2 and also n plus 10. Restrictions, make sure we go through everywhere. So n can't be 9 halves, n can't be negative 2, n can't be negative 1, n can't be negative 10, n can't be negative 1, but we already have it listed. Don't need to list it again. So reduced expression with restrictions. There is our answer. And one more. First off, GCF, those have a 12 in common. Down here, first off, let's think to the side here for a moment. Those are all even, so divide the 2 out. I'm now looking for the two numbers that multiply to 7 and add up to 8. Well, that is 7 and 1. Change to multiply and flip over. So this 2n plus 8 is going to become 2 quantity n plus 4 on the bottom. And then this one here, they have a 20n in common. That's going to leave us with an n plus 4. Let's reduce. N plus 1, n plus 1, n plus 4, n plus 4. 2 goes into 12 6 times, 2 goes into 20 10 times. So what we're left with on the top is 6 times 10 times n, that's 60n. And on the bottom, just n plus 7. Restrictions, make sure we don't divide by 0. N can't be negative 7, n can't be negative 1, n can't be negative 4, and this used to be on the bottom, n cannot be 0. So reduced expression with restrictions, there is your worked out odd problem.